So the topic of this day is EC2. EC2 stands for Elastic Compute Cloud. Elastic Compute Cloud. You will see this term elastic in many different services. We'll discuss that, what exactly elastic means. Now, what's the purpose of Elastic Compute Cloud and why do you need this? So if you see the Elastic Compute Cloud, the purpose is that it provides the resizable compute capacity in the cloud. So it gives you the resizable compute capacity in the cloud. Fine. So it gives you the resizable compute capacity in the cloud. Now, if I say resizable, what do you mean by resizable? This means that this can be resized. It can be changed whenever you want. We'll discuss that in detail. So it gives you the resizable compute capacity in the cloud. That's the purpose of the Elastic Compute Cloud. Now, how this works for you? Let's imagine that this is my AWS cloud. So this is the Amazon Web Services Cloud. This is the AWS cloud. And this is my virtual machine. What's that? This is my virtual machine, or this is my virtual server. Virtual machine / virtual server. Now, if you have any virtual machine or any virtual server that's running in the confinement of the AWS cloud, that's labeled as my EC2 instance. You can also call it as an instance, but generally we label it as an EC2 instance. Now, an EC2 instance is nothing but it's a virtual server or the virtual machine that you deploy in the confinement of the Amazon Web Services Cloud. And it has some compute capabilities. It has some compute capacity. Compute capacity means if I just list down the attributes, the compute capacity includes your virtual CPU. Right? So virtual CPU, it will consist of the virtual CPU, RAM, storage, and GPU, graphical processor unit, etc. So it has some compute capabilities. It has some compute capacity. It has some compute capabilities. It has some compute capacity. Now this can be resized. This can be changed. We'll come to that afterwards. But right now, you have to understand why you need a virtual machine. See, everything you launch, any application, any service that you deploy upon the virtual machine, it runs upon that. So you have to have some compute capability, some compute server, some compute node upon which you can run your applications and services. So the EC2 instance consists of the OS or the operating system. You install upon the operating system upon this instance. So it comes in two different formats. One is the Linux and the other one is the Windows. These are two different types of operating systems you can install upon the EC2 instance. Then you have the applications that you deploy upon your virtual servers plus your services. You also run upon, or you also install the software upon the virtual machine, and also you execute some scripts. So you install everything upon the instance. Operating system, applications, services, software, and scripts. So you install everything upon the instance. That's why you need a virtual machine. That's why you need an EC2 instance. Coming to the compute capacity. This compute capacity is defined by something called instance type. So depending upon what is the instance type you choose, it defines the compute capacity or the compute capability of your instance. So if someone asks you what's an instance type, it's nothing but it's a virtual representation. What's that? It's a virtual representation of underlying physical resources, of underlying physical resources. So it's a virtual representation of the underlying physical resources. It depicts that what amount of CPU, RAM, storage, GPUs is associated to that instance. I give you one example. There's one example I can give you. For example, there's one instance type that we'll use quite often because it's free tier eligible. That's T2.micro. Okay, this is a free tier eligible instance type, and you don't have to pay for it if you use it. It gives you almost one virtual CPU, 1 GB RAM, and it consists of 2.5 gigahertz of Intel's Xeon processor. You can see that it has decent specifications for you to get started. And depending upon what type of operating system you choose, so it gives you 8 or I would say 30 gig of storage on an average. If you have a Linux, you get 8 gig of storage. If you have Windows, you'll get 30 gig of storage. These are the different parameters or different attributes of the T2.micro instance. So these are decent specifications for you to get started and get the hands-on, get your feet wet, and start using the virtual machines or the EC2 instances that you deploy upon the AWS cloud. So you got the idea. You have the virtual machines or the EC2 instance upon which you deploy everything, starting from the operating system, applications, services, software, scripts, and this gives you some compute capacity. It has some compute capabilities. Now, the thing is that I use this term elastic or resize. It's the same thing. What exactly do you mean by this term called resize elastic? This means that you have the flexibility to change the specifications of the instance. For example, right now you have T2.micro, which gives you, let's imagine, 1 GB RAM. This is the amount of RAM you get from this instance type. You want to have a higher instance type because you want to have some more RAM, because 1 gig of RAM is not sufficient for you. Depending upon the type of application services you want to run upon the instance, you want to bump up the RAM you want to get. Now you can change the instance type. So you can very easily change the instance type, for example, M5.xlarge, which might give you, let's suppose, 3 gig of RAM. So you can bump up the specs of the instance by changing the instance type. I'll show you the process. It's a very easy thing. Now, this thing where you add on the specifications. So this concept is called vertical scaling. This is a very common term that we use in the industry. It's called vertical scaling, where you bump up the specs of the existing server. You beef up the servers. You add on more RAM, more CPU, more GPUs, etc. That concept is called vertical scaling. Opposite to it, we have something called horizontal scaling. So I've discussed with you the vertical scaling, where you bump up the specs of the instance. Then you have something called horizontal scaling. Now, horizontal scaling is a kind of a term where you increase the number of instances. For example, right now I have 10 T2.micro instances. Instead of beefing up the servers or adding on more CPUs and RAM to those servers, you increase the numbers. Because there's a high peak in the traffic, there's a high demand. From 10, you can go up to 100. So you can have 100 similar servers. So you have increased your capacity 10 times, from 10 to 100. Also, you have the option to go back. you have this elasticity. You can increase or decrease the number of instances. Okay, so this is how you can resize the compute capacity. Either you can beef up these servers, you can bump up the specs of it by changing the instance type. And if you want, you can also revert back to the previous instance type if you want. And in the horizontal scaling, you bump up the number of instances. And if you want, you can revert back to the same number that you had before. This kind of flexibility and this kind of elasticity you get only in a cloud computing environment, because in a data center environment, it's very tough to achieve this type of flexibility. Okay, now that's why AWS stands for Amazon Web Services. They give you these type of compute nodes in form of the services, and you can use this as a service and you get a lot of flexibility because you can change the specifications or you can increase or decrease the number of instances. That's what this is all about. Now, I'll just do one thing. I just mention some more things over here for you because it's really important that you understand these concepts in detail. The next thing we'll discuss is that how exactly you manage to define these things: the operating system, applications, services, software, and scripts. How exactly you are able to define all these things. Basically, all these things are being encapsulated in the form of AMI, which stands for Amazon Machine Image. Okay, which stands for Amazon Machine Image. So Amazon Machine Image defines the operating system, the applications, services, software, and scripts, which you bundle together in a single package. I'll just show you this thing on the management console. Right now, you have to understand the concepts first. So if you want to understand what's an AMI, I just want to make sure that I just make this concept clear first. An AMI stands for Amazon Machine Image. What's that? It's the Amazon Machine Image. Amazon Machine Image. Now, what is this Amazon Machine Image? It's nothing but it's a pre-configured template. What's that? It's a pre-configured template. Or I would say it's a pre-configured package. It's a single package. It's a single package which consists of all the different attributes, including what it consists of: your operating system, which comes in two different formats. Either it's Linux or it's Windows, plus your applications, your services, your software, and your scripts. You put that in a form of a single package and then they are required to boot your instance from scratch. They are needed or they are required to boot your instance, your EC2 instance from scratch. You need a complete package to boot the instance from scratch. That's the purpose of AMI. It stands for Amazon Machine Image. You need to have this thing, otherwise there will be nothing for you to install upon the operating system, applications, services, software, and scripts upon the instance. You have to have that. Fine. You have to have the Amazon Machine Image that you can install upon the instance. Now, if you see the broad categories, there are multiple categories of the AMI. I discuss all the different categories one by one. So AMI has multiple categories. So I just elaborate those categories right now in front of you. So if I discuss with you each one of them, the first one is the public AMI. Public AMI is the one that's being pre-configured. It is a pre-configured template that anyone can use. It's a pre-configured template. Okay, let me just write down once again. So the thing is that you have to understand this fact that you have different categories of the AMI. So you have different categories. And the first category is the, which AMI? Public AMI. Okay. And what is that? It's a pre-configured, or it's a default template. Pre-configured / default template. Now, anything that you get by default or pre-configured will come with one disadvantage. That is, it will not give you any type of flexibility. Anything that comes pre-configured or it's a default thing, it doesn't give you any type of flexibility. And also, it will not give you any type of customizations. One thing you have to understand, anything that you get by default, it's not customized. It doesn't give you the type of customizations that you need to have. Okay, let me do one thing. I just log into my AWS My console and I show you exactly that how a public AMI looks like. So I shoot back to my AWS My console real quick and show you that how this looks like. So let me just open my management console and I show you from scratch. It's really important that you understand this concept, because this concept is the essence of the other services that we'll discuss in the future. So I just log into the management console real quick and I show you exactly that, how you can leverage the public AMI. So I just logged in and you will see that I just go ahead and go to the EC2. I just go to the EC2 under the compute section. Once I just go to the EC2, from where I can launch my instances. Now, one thing that's very important, before you can launch the instance, you have to choose the preferred availability zone. This thing is of utmost importance. You have to choose the availability zone, not availability zone right now, because availability zone you'll just choose afterwards, but the region, because you can also choose the availability zone, but we have to choose the region first. You have to choose the region first before you can just go ahead and start with the deployment of the instance. Fine. So I just go to the Mumbai as my region. I just go over there. Once I just go to Mumbai as my region, I just go ahead and click on launch instance. Now this entire page that you can see right now, this is my EC2 dashboard. What's that? This is my EC2 dashboard. I click on launch instance right now in front of you, and this is the public AMI page. This is the AMI, this is the Amazon machine image. Now, if you see the definition on the top, if I can highlight the definition, you can see that an AMI is a template that consists of the software configuration, which includes your operating system, application server, and applications that are needed to boot your instance from scratch. Fine. Now, this is a list of the public AMIs. Now, AMIs come in two different flavors. Either they're Linux or they're Windows. You can see that right now, these are the Linux-based AMIs. And the one that you can see free-tier eligible, this one, let me show you. This is free-tier eligible. These are the one that you can use with the free-tier account without paying any charges. Fine. Guys, you can see that you're saying that my screen is stuck. As if now I'm on my public AMI page. Okay. Thank you so much for the confirmation. So over here, what we can see is that these are my public AMIs. The two main flavors of the AMIs, Amazon Linux, or I would say Linux distributions. So for example, Amazon Linux, Red Hat, SUSE Linux, Ubuntu. So these are different Linux distributions. These are different types of Linux-based AMIs. Then down below, these are the Windows-based AMIs. These are the Windows-based AMIs. So I can use any one of these AMIs. These are the public AMIs. I can start using them, and each of the AMIs will consist of the AMI ID. Fine. I can start using them on the fly, but they don't give me any type of customizations. This thing you have to understand. You don't have your own flavor of services and applications running upon them. It's a raw type of public image. You can use it for the demonstration purpose, for the lab purpose, and so on. The main thing that you have to use in a business environment is the My AMIs. On the left hand side, you can see there are different categories. The second category, so this is my public AMI page. Then we have My AMIs. My AMIs is the second category, which means that you can define your own customized AMIs. You can create and manage a complete repository of your own customized AMIs. Now, why you need these type of customized AMIs? This thing you have to understand. Say in a business environment, you have your own custom built application services and you want to have them installed and up and running upon the instances. For that purpose, for that reason, you have to have the customized AMIs. If you don't have the customized AMIs, then you not go anywhere. So the second category that we'll discuss would be the customized AMIs. Customized / my AMIs. So it's your own built, your own configured AMI. Now the thing is that how exactly you manufacture it. I'll show you in a form of a demo session afterwards, but right now you have to understand the concept first, that how a customized AMI is manufactured. This concept is of utmost importance. Let's imagine this is my AWS cloud. This is my AWS cloud, and this is my EC2 instance. What's that? This is my EC2 instance. Fine. Now, upon this EC2 instance, I want to deploy upon some operating system. First thing first, before you can carve out the customized AMI, you have to make use of. So the very first step is that you have to make use of a public AMI to launch this instance. You pick any of the public AMIs and you install the operating system, services, applications upon it. Fine. That's the first step that you have to do. You got the point. To manufacture the customized AMI, the very first step is that you have to make use of a public AMI. Then, in the second step, you have to install your applications, services, let me just write it down. Applications, services, and scripts, or I would say software or scripts upon this instance, and you perform some basic customizations or some advanced customizations. You perform the customizations. So you perform all the different customizations based upon your taste and preference. Okay? You install everything upon the instance and you customize it. That's the second step. Once you're done, the third step is you capture image from it, which becomes your customized / my AMI. This becomes your image. Because once you install everything upon that instance using public AMI and you install your custom built application services and softwares and you perform the customization, in the third step, you capture the image out of it. You capture the image out of it. That's the whole story. That's the process you have to follow to create your own custom built AMIs. That's the main purpose. That's the main thing that you have to perform. Done? So I hope that you understood that process. Now, the thing is, once you have this customized image, this is the final product. You have the customized AMI. That's the final product, or the my AMI. Now, from this customized AMI, you can launch any number of instances, okay, of any instance type, of any instance, let's write it down, of any instance type. Okay, using this customized image, you can launch any number of instances of any instance type. You can launch any number of instances of any instance type, and all the instances will have the same set of services and applications running upon them. All the instances will have the same set of services and applications running upon them. That's the beauty of the customized image. Once you capture it, you can launch any number of instances from it with the same services and applications running upon them. Let's take an example. Let's imagine that this is my AWS cloud, and I launch my EC2 instance. I launch my EC2 instance using a public AMI, for example, an Amazon Linux AMI. So I use this public AMI to deploy my image upon it. Or this is my operating system. Now, this is my first step. In the second step, I deploy upon it the Drupal web application. So let's suppose I deploy upon it the Drupal web application plus my SQL database. Okay. And I perform my customizations. I configure my server, I create the web pages, and so on. Now, in the third step, what I will do, I will capture the image. I'll capture the image from that instance. This image will become my customized AMI. From the customized AMI, I can launch any number of instances. For example, I launch 10 EC2 instances. Now, all the instances will have the same application and services running upon them. Same Drupal web application, MySQL database, all the instances will have the same applications and services running upon them. That's the process of manufacturing the customized image. That's the main process. Fine. That's the main intent. That's the main process. You have to ensure that you deploy the public AMI or you launch the instance using the public AMI, and then you install everything upon it, including the applications and databases. You perform the customizations, and then you capture the image from that instance. That's the process. Okay. Now I just go back to this AMI page real quick. And these are my public AMIs. So if I just go back, these are my public AMIs. And this is the space where I can just maintain my own customized AMIs. I'll show you later on that how you do that. We also have the marketplace. The marketplace is the one where I can just purchase the software from multiple vendors like SAP, Zend, Microsoft, Cisco, Juniper, F5, Trend Micro, and so on in the form of the AMIs. Now, these are the paid AMIs. Most of them, I think you can see that almost 99% of these AMIs are chargeable. You have to pay for them. For example, I want to deploy the Juniper VSX RX next generation firewall. So I just go to this Juniper VSX RX next generation firewall. I click on that. And you can see that if I just use this AMI to deploy the Juniper VSRX next generation firewall, in that case, what happens is that I can see the product details, the latest version, the base operating system, the delivery method, license agreement, and so on. What are the services needed to ensure that I can start deploying the Juniper firewall in AWS? I can scroll down and I can see the usage instructions, support details, infrastructure, and on the right hand side, I can see the pricing details. Now, if I use this, I get a free trial for 30 days. And based upon the instance type that I choose, I have to pay the software fee per hour. This will go to Juniper and the instance fee will go to AWS. You don't have to pay to Juniper. You just pay the collective fee, the total fee. So behind the scenes, 55 cents will go to Juniper. And depending upon the instance type, the instance specification, that amount will be divided and it will be sent to AWS. You just have to pay the total fee. That's it. And also you have to pay the charges for the storage. So this is all about the marketplace. You can explore it. You can get a ton of multiple softwares or the AMIs from the marketplace. Then you have community AMIs. Now the community AMIs are the one which are being used for you to perform the lab sessions or demo sessions. It's a community effort. Anyone, you, me, can create a customized image and publish that on that space. Basically, by default, my AMIs are private in nature. When you create any AMI, it's private in nature. Once you make it public, it gets published in this community AMIs. So anyone can create a custom image and publish that, make it public, and it will show up under the community AMIs. These are all the things that we'll get over here. Now, let's do one thing. I go to the quick start menu and I just go to the Amazon Linux AMI. I use this public AMI to launch my instance. I click on select. Once I go over there, the next thing I will do is that I will choose my instance type. Now, as we have discussed that different types of instance types will give you different types of resources in terms of virtual CPU, RAM, storage, GPUs, etc. It all depends upon you that what type of application services you want to deploy upon the instances and what are the specifications, what are the requirements. Okay, you can see that these are general purpose, these are different families. For example, right now, these are general purpose AMIs. You can use them for any type of purpose. If you don't have any extensive requirement, you can use it generally to deploy any type of web application upon them or even the database. Then you have something called compute optimized. They will give you a higher amount of compute power. Then you have the memory optimized or GPU instances, graphical processing units. Then you have memory optimized, which gives you a higher amount of RAM. So these are different instance families, and each instance family will consist of different type of instance. Now you can see the virtual CPU, RAM, storage. The higher you go, the more you have to pay. The higher you go, the more you have to pay. Now, depending upon the type of services and applications that you'll be running upon the instances, you have to carefully choose instance type. Now, even if you make the mistake, you can always switch back to any other instance type later on. You can perform the vertical scaling and you can change the instance type of the existing instances. Now, there might be a question, how do I get to know which instance type I need to choose from? Because I can see hundreds of them. See, first thing first, any application that you deploy upon the instance, it's obvious that you have some experience deploying or running that application in your own infrastructure. Any application that you run, any service you run, it consumes some compute power, maybe CPU, RAM. So you already have the idea or the knowledge that what type of compute capacity you need to support that application or the applications. For example, the application that I'm running, it needs 16 gig of RAM. So I will say, okay, 16 gig is supported by T2.x large. I'll go with this one. So it's your responsibility that you have to match these specifications, and based upon that, you can choose the instance type. If by mistake you choose any instance type which is not appropriate, you can change it afterwards, even after you have launched the instance. Fine. Now you have to choose the T2.micro instance type if you perform the lab sessions, because this is free of cost. You don't have to pay for it. T2.micro. I click on next configure instance details, and now we can configure a lot of details from scratch. I'll discuss with you some more concepts, few more concepts, because as of now we've discussed the instance type and AMI. These are the components of the instances that I've discussed with you. Let's take it forward and I discuss the next level of concepts. The next thing that we'll discuss would be the IP addresses. See, this is the third component. We discuss the IP addresses. See, why you need the IP addresses? You need to assign the IP addresses to the components of your infrastructure so that there can be a communication between these servers. So these are used for communication. You need to assign the IP addresses so that there's a communication going on between the different servers. In AWS, the three types of IP addresses are being used. I'll just jot down each one of them. Just try to understand their relevance. So the first type of IP address that I'm going to discuss with you is called the private IP address. What's that? That's the private IP address. Now, what's the relevance of private IP address? This is purely used for internal communication. What's that? It's used for internal communication. What do you mean by internal communication? For example, if this is my AWS cloud, and these are my two different instances, A and B, running in the same infrastructure, same cloud, to communicate internally, they'll be using the private IPs. It's the internal communication stuff. So it facilitates the internal communication. And they don't allow external communication. What do I mean by external communication? I'm talking about the internet, because internet is the biggest public cloud you have. So if you use the private IPs, they are not supposed to be used to access the internet. They are not supposed to be used for the external communication or communicate with the internet. So it only facilitates internal communication. That's what we make use of the private IP addresses. It allows the internal communication so that the resources within the same cloud, they can communicate, they can send or receive the traffic to each other, but it doesn't allow the external traffic flow. Okay. Now, the next question really is that who assigns them? Okay, let's do one thing. Let's understand the ranges first. What are the ranges that they fall into? Because every type of IP address will have a certain range. This is the range of the private IP addresses 10.x.x.x. Then we have 172.16.x.x, and it will go up to 172.31. Let's write it once again. .31.x.x, and then we have 192.168.x.x. Over here, x denotes any number between 0 to 255. These are the ranges of the private IP addresses. This is the range in which they fall into. So whenever you structure the private IPs, you have to make use of these ranges. These are industry standard. It's nothing new with AWS. These are the industry standard private IPs. These are industry standard. Fine. So these are the three ranges that they fall into. So it's used for internal communication, and these are the ranges. Now, the next question really says, who assigns them? Who assigns these private IPs? Basically, it's the architect who structures the private IP. The architect is the solutions architect, the one that deploys the stuff, provision the instances, facilitates the assigning of the private IPs. Okay. So if you structure the entire network by yourself, you define the private IP address of the network and the instance. Right? So who assigns them? The architect. Is there any price for this? Is there any cost involved if you use this service? What's the pricing? It is free. No charge for this. Okay. Also, they are static in nature, which means that they will be intacted to the instance until the instance is being deleted. So it will stay with the instance till its lifetime. Okay. So this is about the private IP address ranges. And these are the three ranges. These are industry standard. We don't have any more ranges. These are the three ones that we use in the industry. These are predefined. Even if you check your data center, these are being used. Okay, this is nothing new. These things have been used we have been using from past many decades. Then the second one is the public IP address. Now, as the name implies, it's used for the public communication. It's used for external / internet communication. It's used for external / internet communication. What I mean by that, for example, this is the AWS cloud, and you want to have the resources within AWS being accessed by the biggest public cloud resources, which is internet. Then you have to make use of the public IP. So your EC2 instance should have a public IP so that it can communicate with the internet. It's used for external communication. Now, what are the ranges they fall into? This is the next thing you have to understand. See, they can have any range except they can fall into any of the ranges except the private IP range. So I've shown you the private IP address range. And there's one more private IP that we don't use anywhere. This is the loopback IP 127.0.0.1. This is the loopback IP address, loopback IP. We use this for troubleshooting. So these are the two ranges that we don't use in the public IP, except that any range will be a public IP address range. Fine. The next question that comes in, that who assigns them? This is a very important fact for you to understand. Who assigns these public IPs? AWS can assign it automatically, or it's the client, or I would say the architect who defines the public IP. If you use AWS, or if you have AWS assign the public IPs automatically, there's no charge, it's free of cost. But if you use your own IPs, there's a concept called bring your own IP. Bring your own IP, where you lease out some public IPs from your service providers and you pay them, and you can use those public IPs on AWS. To have the uniformity of the entire design, you can bring your own IPs. You can lease them out from the service providers and use them on AWS. Fine. And there's one thing you have to understand. It is dynamic in nature. This means that if your server restarts, it will change. It's not permanent. If I say dynamic, it is not permanent. It can change. It is subjected to change. It is subjected to change. I'll elaborate this point afterwards, but you have to understand this concept first. And of course, once we move forward, I'll show you in detail that how you implement this entire stuff. So we discussed the two IP address types. The third one is the one that we use in AWS explicitly. These two we use in the industry, the public and private IP. If you check out any of the network diagrams, or you just check out your documentation, if you fetch any document that's there in your company's repository that shows the entire network diagram of the resources, you can see that the IP addresses are being assigned to these servers and different resources. So it's an industry standard thing that we use. The third thing that is just relevant to AWS is the Elastic IP. Elastic IPs are same as public IPs, are same as the public IPs. Okay? And they're used for external / internet communication. However, they are static, or they are permanent in nature. They never change. Now, this is of the biggest benefit for you, because in few cases, if you deploy some websites upon the instances, you have to have the static IPs assigned to them. For example, I just give you one single example. Don't be too much concerned about the example. Just try to understand the essence of it. Let's imagine this is my AWS cloud. And this is my EC2 instance. Fine. Now, upon this EC2 instance, I have deployed a WordPress site. A WordPress site. Now, how I allow the external users to reach my website? For example, these are my internet users. These are my end/internet users. How they will reach my website? I'll give them a domain. So I will give them a domain. They will type in, for example, xyz.com. It will hit the DNS server, which will translate to the public IP address of the instance. If you today you type in something called google.com, facebook.com, any website you type in, it gets converted to the IP address of the server behind the scenes. The DNS server takes input and converts to the public IP so that you can reach the website running upon that server. The problem here is that if your instance restarts, if you restart your instance for any reason, this public IP gets lost in between. It's released and your instance will then get a new public IP. A new public IP. So you have to go to a DNS server and match the domain with a new public IP. So this adds on some more overhead upon you, more task for you. It's a burden for you because every time your instance restarts, you have to map your domain to the new public IP. To fix this, you assign this instance an elastic IP which never changes. It is same as public IP, but even if you restart the instance, this never changes by itself. So you link your domain, for example, xyz.com to the elastic IP, and if your instance restarts, it never changes. So it is static in nature. It is static in nature. We'll discuss that in detail afterwards. Right now, you have to understand the concept first. The question really is now, how you're being charged for that? What's the pricing? See, you get 5 elastic IPs, EIPs for free. Okay, you get 5 elastic IPs per region. Each region, this is free of cost. And this is the maximum limit you can go up to. You can't have more than 5 elastic IPs in any region. Okay. And this is applicable for any account type, whether it's a business or it's a free tier. This is applicable to any account type. Fine. So 5 elastic IPs per region, free of cost, and that's the maximum limit you can go up to. You can't go beyond that. However, they will charge you if you assign the elastic IPs to stopped instances for longer duration, or you have them just sitting idle and not being attached to any instance. So if you waste them, if you don't use them properly, they will start charging you because it's a scarce resource. Elastic IPs and public IPs are scarce resources. There's a scarcity of these IPs. These are scarce resources. So it is very important that you should always have the elastic IPs assigned to running instances. Don't keep them just sitting idle, which means that if I'm saying sitting idle, this means that they are not attached to any instance. And don't assign them, keep them assigned to these stopped instances. We'll discuss these things in detail afterwards. Right now, you have to just understand the concept. So these are the 3 types of IPs we make use of in our AWS infrastructure. Done? Okay. The next thing we'll discuss is the VPC. After we discuss the IP addresses, the next thing we have to discuss is the VPC. Now, there's a complete section on the VPC that we discuss in detail because once we launch the instance, we have to choose a VPC. Hence, it's important that you understand the basics of it first. So, what is VPC, by the way? VPC stands for Virtual Private Cloud. What's that? It's a virtual private cloud. Basically, it's nothing but it's a virtual data center that you deploy upon the AWS infrastructure. See, the question really is why you need to have this virtual data center? What happens is, if you look into AWS is a public cloud. It's not a private cloud, it's a public cloud. Because anyone, you, me, your competitor, can sign up for AWS and start deploying the services and applications without any verification. The problem arises is that now you don't feel comfortable because your resources will be visible, or they might be visible to your competitor or other organizations. So how you can get some seclusion, or you want to get some privacy? You make use of this virtual data center. This virtual data center is called the virtual private cloud. In that case, every organization will have its own VPC. Let's imagine this is my VPC, which belongs to Wipro. This is my VPC, which belongs to AIG. This is a third VPC, which belongs to Accenture. This is my fourth VPC, which might belong to, for example, SpaceX. Every single organization will have its own virtual data center, its own cloud. Even though they are resting on the same public platform, the same public cloud, that's AWS, but they have kept themselves isolated. There's no communication by default. By default, there's no communication. So this gives you the isolation, the privacy. So what are the benefits you get out of it? The benefits that you get from this VPC is, first one is that it gives you enhanced security. What's that? It gives you enhanced security. It gives you the transparency. What's that? It gives you the transparency. Also, it gives you the flexibility. You can flexibly define the resources without any issues. It gives you the amount of flexibility you aspire for. Enhanced security, transparency, flexibility. So these are the three main benefits that you get. Also, you can say that you get the isolation. These are the four main benefits of using the VPC, which is nothing but it's a virtual data center that you deploy upon the public cloud platform. That's the Amazon Web Services. You got the point. Okay, that's the concept of VPC, which stands for Virtual Private Cloud. Now, how you structure it? I'm just giving you the basic concept. Try to understand the concept, because once we discuss the VPC in detail afterwards, there's a complete section upon it. We'll discuss these things in detail. Yeah, we'll discuss in detail. Now, if I say transparency, this means that you can look into your resources in much more depth. Let's imagine this cloud is my VPC. Now, a VPC is, or it stays in a region, because a VPC is a region specific resource. So let's assume this VPC is in Mumbai. This VPC is in Mumbai. And each VPC will be assigned a private IP address block. It's called, okay, I just make it simple for you. It's a private IP block. So you have to make use of a private IP block to define the VPC. For example, 10.0.0.0/16. Now, you don't go into details as if now. I discuss with you what this /16 means. So you just have to understand, you assign a private IP address range to a VPC, right? Then within the VPC, you structure or you carve out the subnets. So these are my subnets. These are my rectangular blocks. What are these? These are my subnets. These two are my subnets. Now, what is a subnet, by the way? Okay, let me just do one thing. Let me just... So these rectangular block, for example, this is my subnet A, and this is my subnet B, right? The question really is, what's a subnet? The answer is, a subnet is a complete block of private IP addresses which consists of your EC2 instances. EC2 instances or your database instances. It's a complete block of private IPs which consist of your EC2 instances or database instances. Now, each of these subnets will be linked to a specific availability zone in your region. For example, this is my subnet A that belongs to AP South 1A availability zone. This is my subnet B that belongs to AP South 1B availability zone. So I've structured the subnets. Now, maximum you can have up to 256 subnets maximum in a VPC. Okay, maximum. Each subnet can be linked to a specific zone. And you launch your instances, for example, these are your EC2 instances inside these subnets A, B, C, D. These are your instances. That's how you structure the VPC. You keep the instances inside these subnets, and each one of these subnets is linked to a specific zone. This is a network overview. This is your networking infrastructure or architecture. From the network perspective, that's how you place your instances inside the subnets, and each of these subnets will be linked to a specific AZ or the availability zone. Fine. And your instances will get the private IPs from the subnet range. For example, instance A will get its private IP from the range of the subnet. For example, this instance A will get 10.0.2.2/32 because the complete range of subnet is 10.0.2.0/32. You don't have to go into details right now. For example, for subnet B, the range is 10.0.3.0/24. And instance C will get its private IP, for example, 10.0.3.3/24. Your instances will get the private IPs from the subnet range, from the range of the subnet. From the range of the subnet they belong to. Your instances will get the private IP addresses from the range of the subnets they are launched into, so that they can communicate internally. They can communicate internally and they can access each other. The traffic can flow internally between these two different subnets and instances. This is the basic concept. I'll deep dive in afterwards because as an architect, you should know how to create this entire infrastructure. We'll deep dive in. We'll discuss all the things in detail afterwards, not right now. Right now, I'm just creating the foundation for you so that in the future, you can easily understand how exactly the things are being placed. All right. This is about the VPC. That's all about the virtual private cloud. VPC and your private IP addresses of the instances is being fetched from the subnet range. Okay. The next concept I'll discuss with you is the pricing. See, we'll discuss the pricing in detail afterwards. I'll also show you the website. You have different types of pricing mechanisms, that how you are being charged for the usage of different resources, especially the instances, because the EC2 instances, they will form a major part of your billing component. This is the component that will take a lot of space in your billing part. So you have to pay a lot of charges for the usage of the EC2. It's very important that you understand that you have to understand that how you're being charged for the usage of the instances. The first pricing model is called on demand. On demand means that you are being charged based upon the number of hours consumed. It's the number of hours consumed. It is strictly the time-based consumption model. Okay? It's a number of hours consumed. It's on demand. It's on your demand. There's no long-term commitment. If you don't want this thing, you can see. Thing is that if I say no long-term commitment, you run the instances for maybe 1 hour or 2 hours and you stop the instance, and you just have to pay for the amount of hours consumed. Okay? So, for example, I just run the instance for only 2 hours and then I stop it. I have to pay only for these 2 hours. That's it. There's no long-term commitment. I don't have any long-term contract with the Amazon Web Services. Okay? So this is the basic concept of on demand. You pay for the number of hours consumed. There's no long-term commitment. But it has a downside. The downside is that there's no partial hour billing. There's no partial hour billing. What do you mean by that? Which means that even if you run the instance for less than 1 hour, you'll be charged for complete 1 hour. For example, I run the instance, so I run the instance for just 10 minutes. Still, in that case, they will charge me for complete 1 hour or 60 minutes. There's no partial hour billing. Even if you run the instance for 10 seconds or 10 milliseconds, you'll be charged for the complete 1 hour. This is a very big disadvantage that it comes with it. There's no partial hour billing. Even if you run the instance for less than 1 hour, you have to pay for the complete hour. Okay? So there's no partial hour billing. Then the second thing that you have to understand is reserved. This is another billing model that you'll be using in the business environment the most. Here you reserve your compute capacity. You reserve the compute capacity. If I say you reserve the compute capacity, I'm talking about the instances. You reserve them for 1 year or 3-year contract. For 1 or 3-year contract. You reserve them. Okay? For example, I can say that I want to reserve 10 M5.2x large instances for 3 years. I want to reserve them for 3 years. I want to come into a contract. The question really is, what's the advantage? Why don't you reserve the instances? Because if you compare that, so compared to on demand, you get up to 70% discount. If you compare that with the on-demand, you get up to 70% discount. For example, if one M5.2x large instance cost me $1 per hour, so might be that if I reserve it, I have to pay, let's suppose, 30 cents per hour. So in longer terms, I save my cost. I reserve my compute capacity for 1 year or 3 year. There's no 2 year, 1 year or 3 year contract. And I just make sure that I can get some subsidies. I get the discounts. So if you have a long-term vision with AWS, if you have a long-term vision, you can go ahead and reserve your compute capacity. Also, you have the third one that you will not use quite often. It's called spot pricing. It's mainly used for the lab purpose, experimentation, or you want to transcode some media. So it's used for lab purpose. Basically, it's used by university students. Lab purpose. It's used for experimentation. And it's used for, let's suppose, media transcoding. Media transcoding means that you convert the videos into multiple formats. For example, you have 100 MP4 videos. You want to convert it to the AVI format. Okay, you want a lot of compute power in that case. Now, the thing is that you get up to 90% discount compared to on demand. It's very cheap. But the thing is that you have to bid for it. So what you do is that you do the bidding. You bid for unused compute capacity. You do the bidding. So the thing is that you give your bid price, and so the thing is that if your bid price, you do the bidding, if your bid price is more than spot market price, then you are being given that instance. But it's not permanent. This is not permanent. This is not permanent. If someone bids higher than you, then in that case, the instance is taken away from you, terminated, and given to that other user. It's not permanent. Your instance can be terminated anytime. Yes, of course, there's some exceptions to it. And the instance will be terminated and given to the other user who has given the higher bid. This is a temporary type of instance which you use for lab purpose, experimentation, media transcoding. You will rarely use it in your business environment. Okay, so don't focus upon that much. You need to focus upon the first two, on demand, reserved, spot, and I'll discuss with you two more that you'll be using in your business environment. The fourth one that you'll be using would be the dedicated host. Dedicated host. Okay. What happens is, in this case, you dedicate yourself, or you allocate a complete physical server. You get a complete physical server for your use. Now, why you want to deploy or have a complete physical server for you? Because there are few exceptions where you might need to go with a complete physical server. First of all, let's understand how exactly at the server level, at the hardware level, the things are being managed. See, what happens is, in AWS, there are two types of tenancies. Let's try to understand that. Two types of tenancies. One is shared, and the other one is dedicated. What's the difference? See, if you go with a shared tenancy, you have this physical server. Let's imagine this is your physical server. This is your HP, IBM, or Dell physical server. And these are the small virtual machines. These are the EC2 instances. These EC2 instances may belong to separate individuals or organizations. For example, these two belong to Wipro. This belongs to HCL. These two belong to Adobe. So, on the same physical machine, you have the instances running and they're being shared among different individuals or organizations. This type of tenancy is free of cost. You don't have to pay for this tenancy. I'm not talking about the instance cost. This is the tenancy cost. This tenancy is free of cost. You don't have to pay for it. Now, sometimes you have to go with dedicated because due to some software, legal requirements or security requirements, you might go with dedicated. Now, one thing, at the shared tenancy level, you get the instance isolation. You get the instance isolation. No two instances can talk to each other. You get the instance isolation. So AWS guarantees you the instance isolation. AWS guarantees you the instance isolation. However, due to some legal, security, compliance, and software requirements, this might not be suitable to you. I give you one example. There's one example I can give you. For example, the Oracle Enterprise Edition database. If you want to leverage this database on AWS, it does not support the shared tenancy instance. It does not support shared tenancy. You have to install or deploy the Oracle Enterprise Edition database on a dedicated physical host. So what happens in a dedicated physical host? It's a dedicated tenancy. So in terms of dedicated tenancy / host, what happens is you have the same physical server, the same HP, IBM, or it's a Dell physical server. You have the same physical server, and these instances that are running on the physical server would belong to you because you have dedicated yourself the entire physical server. This is owned by you. This is owned by you. Either you can pay for it on demand, hourly basis, or you reserve it. In most cases, you reserve it. Okay? Where you book it for 1 year or 3-year contract, the entire physical server. This means that all these instances would be yours. You will not allow anyone to deploy their instances on the same physical host because you own that physical server. It's a private physical server. It's your private physical server. You got the point? That's what it means. Fine. That's about the entire stuff. So these are two types of tenancies that you can opt for. Now, dedicated tenancy, as I said before, it's not free. You have to pay either on demand or you pay or you reserve that. Okay. The fifth and the last one that I'm going to discuss with you is not used that much in a business environment. This is the per second billing, where you are being charged based upon the number of seconds consumed. Number of seconds consumed. Now, why you go with this number of seconds consumed? Why you go with this type of billing model? Because if you go with the on-demand, the major problem with the on-demand is that there's no partial hour billing. If you see the on-demand, there's no partial hour billing. To solve this problem, you can go with the fifth option, that's a per second billing, which means that you pay for the instance usage on pro rata basis. Okay, so instead of paying for the number of hours, you pay for the number of seconds consumed. However, you have to run the instance, you have to run the machine or instance, run the instance for 60 seconds at least, not less than that, for 60 seconds at least. And as of now, it supports only 2 AMIs, Amazon, Linux, and it also supports the Ubuntu. It only supports the Amazon Linux and Ubuntu Linux AMI machines or instances. These are the only 2 AMIs that support this per second billing as of now, right? You are being charged for the number of seconds consumed. You run the instance for 60 seconds at least, and these are the only 2 AMIs that support it. This is how you're being billed for the instance usage. That's how you're being billed for the instance usage. You got the point? All right. That's how you are being charged. So over here, the next concept I'll discuss with you is called CloudWatch. Okay. The next concept I'll discuss with you is called CloudWatch. See, CloudWatch, there's a separate topic on that, but because it's a part of the instance configuration, I have to discuss with you. What is CloudWatch? See, CloudWatch is nothing but it's a default monitoring tool. It's a default monitoring tool. How this works for you? Monitoring means that it will gauge upon the performance of your resources. How this works? For example, this is my EC2 instance. I just simplify this concept for you right now. And CloudWatch is a separate service. CloudWatch will gauge upon the performance of the instance. And there's a frequency. If the frequency is 5 minutes, it comes under the concept of standard monitoring, where CloudWatch will analyze the instance performance after every 5 minutes. You can, as an admin, you can log into the CloudWatch and see the exact performance. But if you want to make it fast and make it more, I would say you want to get the updates faster, you can also go with the 1 minute frequency. It's a 1 minute frequency. Okay, one thing, the standard monitoring is free of cost. You don't have to pay for it. If you go with a 1 minute frequency, which means that the CloudWatch analyzes the instance performance after every 1 minute. It's called detailed monitoring. And you have to pay for it. This is chargeable. So these are the 2 flavors of CloudWatch monitoring. You might get a question. You may get a question from this stuff. So I just go to the this page and I just include those things that I've discussed with you. Right now, I discuss with you a few things. I'll apply the same things over here. So first thing first, I choose the number of instances. I can just mention 10, 20, whatever number I want. So I just launch only one instance right now. Auto scaling group is a different feature. We'll discuss that afterwards. We can deploy the instance in one single auto scaling group. But as of now, I will not use this option. Basically, it is used to promote automation. As of now, I will not automate anything. Purchasing option. By default, it's the on-demand purchasing or pricing we are using. If you check this off, it becomes spot. We can bid for it. But right now, because we're using feature account, we'll be using the on-demand pricing. Network. Now, this is the VPC, the virtual private cloud I was talking about. So I discussed this concept with you. VPC, right? So what's a VPC? It's a virtual private cloud. It consists of subnets, and each subnet is linked to a different zone. So, having said that, I can choose my VPC. This is my default VPC. And if I choose this subnet of the VPC, in that case, I'll be launching. Okay, my page got refreshed. Let me just go back once again. So if I choose this subnet, in that case, my instance will be launched in AP South 1A. If I use the second subnet, then my instance will be launched in AP South 1B. And 4091 IP addresses available. This means that these many instances, these additional instances I can launch in the subnet. However, AWS recommends that you choose no preference, because if you choose no preference, in that case, what happens? That if you choose no preference, then AWS will launch your instance in any of the best available zones or subnets by itself. But you have the privilege, you can choose any subnet of your own choice. Then, one thing, that your instance will get the private IP address range from the subnet range by itself. But as an architect, once you move forward, you structure the VPC and the subnet by yourself. Then you also have the public IP. You can also assign the public IP address to the instance so that it can be used for external communication. By default, it's enabled. If you want, you can disable it. But I want to enable the public IP address because I want to communicate with that instance using the concept of the public IPs. Okay. Then we have placement group and capacity reservation. These are two separate concepts. I'll discuss these concepts with you later on. We're going to skip them as of now. IAM role. We discussed the IAM role. I can choose this IAM role so that this instance can communicate with my buckets in the future. And if I want to add more subnets, I can click on create new subnet and I can just add on more subnets by clicking over here. Then we have shutdown behavior. Shutdown behavior are two. By default, it's stop. If I shut down the instance, I want to stop it. If I choose terminate, in that case, terminate means that you permanently kill the instance. If you terminate an instance, you can't get it back. You can't get back an instance which is terminated. So I will choose stop. Now let's suppose this instance that you are just in the process of launching, it's a very important instance for you. You can't afford to lose it. Maybe this instance is a master server in your Hadoop cluster. So you want to prevent any type of accidental termination because might be this instance is being shared among 100 IAM users and someone can by mistake terminate or delete this instance by mistake. So I can check this option so that I give immunity to this instance. The termination option get grayed out. No one can accidentally terminate or delete the instance because the termination option would be grayed out or would be disabled. Monitoring. I've discussed with you there are two types of monitoring, standard or detailed. By default, it would be standard, which has a 5-minute frequency. It is free of cost. But if I check this option, CloudWatch detailed monitoring, which has a 1-minute frequency, in that case you have to pay for it. So I'm gonna uncheck it and keep or stick to the standard CloudWatch monitoring. Tenancy, we discussed that. Shared and dedicated. Shared means that I can have my instances up and running on a shared physical server, but I don't have to pay for it. I can also go with a dedicated where I run my instance on a dedicated physical server and have to pay for it. Okay. T2, T3 unlimited. Usually you don't use that in any business environment. Basically, if your instance wants a very high CPU performance, if an instance wants very high CPU performance, then it can burst the CPU credits of it. Basically, don't use that in any business environment. I can also add a file system. upon this instance like Elastic File System, but as of now, I will skip it. Network interface, this is the default Elastic network interface attached to this instance. Okay, we're going to accept the default values. Under advanced details, I can mention a script like a Python script, a Bash script, a Perl script, so that once this instance gets launched, I can have the services and applications deployed upon the instance automatically. Okay, that's about the advanced details. Now, I just go to NextAdd storage. You can add on the EBS volume, the Elastic Block Store volume to the instance. There's a complete lecture on the EBS. We'll discuss that in detail afterwards. It's nothing but it's a virtual disk. It's a virtual storage that we assign to the instance. Like you're using a laptop or computer, it has a hard disk embedded into that. Similarly, you have a virtual disk linked to this virtual machine, so that we can use this virtual hard disk to boot the instance, and you can install upon the operating system upon it. It can consist of the program files, your documents, and your data. By default, it will allow me to assign 8 GB or 8 gig of storage, the EBS volume. This is the EBS volume, Elastic Block Store volume. It's a kind of a virtual hard disk. You allocate to the instance, and the maximum size you can go up to is 16 terabyte. These are different types of volumes. We'll discuss these different types of volumes later on when the time comes. And based upon the type of volume you choose, these are different performance parameters. We'll discuss that thing later on once we discuss EBS in detail afterwards. If I uncheck this option, delete or termination, in that case, I make this volume independent from the instance lifecycle. This means that if this instance that I'm launching, I terminate or delete the instance in the future, in that case, this 8 GB of hard disk will not be deleted. Will not be deleted. Okay. Also, I can perform the encryption of the volume if I want. So if I uncheck this option, delete on termination, in this case, if we terminate the instance in the future, this volume will not be deleted. I click on next add tags. Now we discuss the purpose of tag. We can add a tag. For example, tag key is name, and the value is type in Amazon Linux instance, and the tag will be assigned to the instance and the volumes. Basically, we assign the tag to the instance so that we can recognize instance, because we may have hundreds of instances on a single dashboard. So we can tag the instance so that we can easily differentiate between multiple instances running on the same instance dashboard. Also, it will help us to extract the billing reports. Then we just click on next configure security group. Now the security group is nothing but it's a virtual firewall that you assign to the instance. Basically, you assign the security group to the instances so that you can restrict the incoming and the outgoing traffic with respect to the instances. A security group is a set of firewall rules that control the traffic for your instance. So you restrict the incoming and the outgoing traffic with respect to the instance. Okay, let me just discuss with you how it operates, how it works for you. So let's imagine, let me just go back to my iPad screen. This is a very important concept, and this is the first step towards the enhancement of the security. This thing you have to configure properly so that you prevent your instance from some unwanted traffic. Okay. So what's a security group? Just try to understand the concept right now, and I just show you the configuration. So a security group is nothing more than it's a virtual firewall. What's that? It's a virtual firewall. you make use of that virtual firewall to restrict the incoming and the outgoing traffic with respect to the instance. For example, this is my instance. This is my EC2 instance. Okay. And this is the instance that I'm just up and running. Now, to restrict the incoming traffic, this is my incoming traffic. And this is my outgoing traffic. So incoming means that the traffic that reaches my instance, that hits my instance, and the outgoing traffic means that the traffic that's being generated by the instance, that's outgoing. You filter the incoming or the outgoing traffic using this virtual firewall that we call it as a security group. Okay, it's a virtual firewall. Now, we apply the filters, 3 main filters to perform the restrictions. What are the 3 main filters we make use of? So the 3 main filters that we make use of are the following. The 3 main filters are, the first one is the protocol. The second filter is port. And the main filter that we use is the source/destination IP addresses. Source/destination IP address or addresses. These are the 3 main filters you make use of to perform the restrictions. It's very, very important that you apply this thing properly. Let's take one example. Let's imagine that this is the AWS cloud. And this is your EC2 Linux instance. You're using a Linux-based operating system to run this instance. Now, this is you. You are the administrator. Okay, so you're sitting in your office. You want to use internet as a medium to get a connectivity to the EC2 Linux instance. So from outside or from anywhere, you'll be initiating the SSH connection. SSH stands for Secure Shell. It's a protocol that you use to get connected to the Linux instances. Only Linux. Secure Shell. It uses port 22. What's a port it uses? 22. Now, it's very important that you, because this will give the root access to the instance, root access, the command line access to the instance. It's very important that you allow it from the known source IP. So from the known IP, it should be allowed. So might be you're using a laptop or a machine. It has the IP address like 57.28.29.35. Every machine gets an IP address. So this IP address should be used to initiate the SSH access to the Linux instance, because you're getting the root access, the admin access. Similarly, if you use a Windows instance, let's suppose that this is your Windows instance now. So this is my AWS cloud, and this is my EC2 Windows instance. Now for the Windows instance, use a different type of protocol. So for example, this is you. Okay. To get the root access to the Windows instance, you choose the protocol RDP for the Windows. That stands for Remote Desktop Protocol. It uses the port, static port 3389. Okay. So if you want to get the root access to your Windows instance, you have to use this protocol and port. So it should be allowed from the known source IP. You can't allow it from anywhere, from the known source IP. Okay, so that's about the getting the root access to the Linux and Windows instances. Okay, let's forget about Linux or Windows. Let's take a third example. This is your AWS cloud. And this is your instance. It can be Linux instance or it can be Windows instance. It can be any of these two different instances. The main thing that I want to focus upon is that upon this instance, you are running a Drupal website, a Drupal web application, or a website. Now you have the external users. These are your end users or external users who want to browse your website. Okay, so they should be able to send the HTTP. They should be able to send the HTTP request. Now HTTP uses port 80. And if you want to encrypt it, you can use the HTTPS, which uses port 443. So if you want to allow the web traffic, the web access by the end users, you allow the HTTP or HTTPS. But the thing is that you have to also define the IP address. What should be the source IP? The source IP is any IP now. The source IP is any IP. Anyone can browse a website. Okay? And any IP is this IP. 0.0. Let's write it down once again. So it is 0.0.0.0.0/0. This is any IP. You allow anyone to browse a website running upon the instance, but the root access is given to the known IP addresses. Okay, it's like anyone can ring your bell, but you only allow the known people to come into your house. So the end users or external users can browse a website, but the root access is given to only your admin users, the known people who can get to the core of the instance and perform the patching, maintenance, software installation, and so on. Okay, this is the concept of the security group. I give you one example where I just encapsulate all these three examples. This Linux one, Windows one, and this one. I'll just take one example where I discuss all these three things in one single example. So in this example, let's try it once again. So in this example, let's imagine this is the AWS cloud. Fine. This is my EC2 Linux instance. Okay. This is your branch office. These are your windows. This is your corporate / your branch office. Okay, where all your administrators sit. On the left hand side, these are your internet / end users, right? Now, upon this Amazon Linux instance, you have deployed a WordPress site, a blog. Fine. Now, the people in your branch office, because every branch office, every data center, this can be your data center. Every single office will have an IP address range. Every single office it leases out an IP address from the service provider. For example, this branch office has this IP address range of 54.72.0.0/16. And people sitting in your office need to get the root access to the instance to perform day-to-day operations. Might be customizing the website, installing the software, patching, maintenance, and so on. So I will say SSH, which uses port 22, will be allowed from this IP address range. Okay? And what about these people who want to access my website? They don't need to access my WordPress site. So I'm saying that the HTTP, which uses port 80, and HTTPS, which uses port 443, will be allowed from anywhere, 0.0.0.0/0. This means that any user can browse the website running upon my instance, but the root access I'm giving to the people in my office, the AWS architects, system administrators, and so on. So it's very important that you segregate the incoming traffic that's coming to your instance by making use of this virtual firewall, which is my security group. Okay? So I'll do one thing. I just shoot back to my AWS management console, and then I need to create a new group. So let's name it as Amazon. So you can assign any name to it. Amazon Linux SG. SG stands for security group. And I can briefly describe this group. This SG will be assigned to my Linux web servers. So you can assign the same group to multiple servers. Fine. And then the next thing I will do is that I just choose the SSH, for example. SSH is given the root access because this is the Linux instance. This is the Linux instance. So I'll be using the SSH, and then the source is anywhere. Now you should not allow the root access from anywhere. You can see the warning message. Rules with the source 0.0.0.0/0 allow all the IP addresses to access your instance. We recommend setting the security group rules to allow access from known IP addresses only. Okay? So you should allow the SSH from the known IP. So I can choose, for example, my IP. If I choose my IP, it automatically picks the IP address of your computer, the present IP address that your computer is getting right now. So I'm using iMac. This is what the IP address of my machine. I can also choose a custom range of my branch office. So I can say this is the custom range of my branch office. Okay. So I can say SSH from my branch office. Okay. And then I can say that the HTTP can be allowed from anywhere. So I will say HTTP access from anywhere. And I can say that I need to allow the HTTPS from anywhere. HTTPS from anywhere. So can you relate this to the example that I've shown you? I'm giving the root access to my branch office, but the web access is given to the end users, any IP address. I click on review and launch. Okay, let me just go back. Yeah, I can just click on review and launch. I can review the screen. I can review all the parameters and I can change them as if now, but presently everything looks perfect. I click launch. Now this is the method of authentication. To authenticate and get access to the instance, use two keys, public key that's being embedded into your AMI, and the private key that you store on your desktop. I'll show you later on that how you authenticate. So basically, you match the private key with the public key. It's being embedded into your AMI. So you have to create a new key pair for authentication, and you have to name it. For example, I'll name it as AWS AMZN-KP. That's it. That's the name of my key pair that I'll be using for authentication. It will have two keys. Public key that will be stored by AWS. It will be embedded into my AMI. And the private key copy, I will store that. In the future, if you want to authenticate, I'll match the private key with the public key. And if the match is correct, I'll be able to authenticate and get access to my instance. I'll click on download key pair. It downloads the private key on your computer. And let me show you the copy of it. It will be downloaded in the downloads folder of your computer. This is the complete algorithm. I'll show you that how you use it. You'll be using it for the authentication purpose. I go ahead and click on launch instances, and my instance is being launched. You can see that it says your instances are now launching. I just go to the instance dashboard, and you can see that it's in the process of getting launched. And you can see it got the public IP, the private IP. I can see all the details under description. That's a process you need to follow to launch the instance.